All right, 7.1, estimating a population proportion. We are going to make, making inferences, wrong tense form of that word, from samples about populations. So here's the idea. Here's our sample, here's our population. What's the difference between them? And then finding confidence intervals and sample sizes which lead us to the population proportion. All right? First vocab word, point estimate. It's any single value used to estimate a population parameter. A very common one is the proportion, p-hat, as it's known. It is a point estimate of p being the population parameter. It's an unbiased estimator, which means it targets, right? The more often you do it, the closer you get to p. Example, simple example here, Gallup poll, interviewed 1,487 people, 43% of those adults had a Facebook page. Hurrah. What proportion or what portion of the US population has a Facebook page? So in this case, our proportion parameter is 0.43. So guess what? Surprise, surprise, with some confidence, more on that word some, is 0.43. So notice it is identical, right? Not identical, but very close. So the question then becomes, how confident are we? We're going to talk about a phrase known as the confidence interval, and that refers to a range of values that's used to estimate the true population. I will abbreviate the confidence interval with CI, capitals. How do you find the confidence level? You are going to take 1 minus alpha, and this represents the probability that your confidence interval contains the population parameter. It'll become more apparent what that means, aka what is the degree of confidence. Now keep in mind, if you have a 90% confidence level, that means your alpha is 10. That means there's 10% where there is no confidence. It's not just chance. So here's an example. Again, 1,487 people interpret the confidence interval that's given to us by this value here. More on how do we come up with that in another example. But how do you read that? 95% confident that the interval from 0.405 to 0.455 actually does contain the true value p. And this means that if you take many samples of similar size, 95% of them would contain p. So there's a picture of what that would look like. All right, each of those bars represents a particular sample that we took. Some of them will contain the p-value that we're after, okay? One of them here, out of 20, won't. Here's what it doesn't mean. Be careful, that's the sad face. There is a 95% chance that the true value of p will fall between 0.4505 or 0.455. P is fixed. It's not a random variable that varies, all right? So confident that the interval contains P. That's how we want to be thinking about the confidence interval. Before we can talk about the confidence interval and how to find it, we need to talk about critical values. Critical values are values from the Z-chart that separate significant from non-significant ones. And the most common one that we talk about here is Z sub alpha minus 2. This is a critical Z-score that divides the no confidence zone into two areas. So here's a good picture of it. That green area, notice how there's one here and one here. So alpha divided by 2 is kind of that zone on each side of the critical value. In this case here, our critical value is here and here. So find the corresponding Z-value for what we call the 95% confidence interval. Going back, there are 3 main confidence intervals that you need to be aware of. Typically, studies fall into one of those 3 categories. Obviously, the more confident you are, the better the study is, but that means typically the harder it is to reach that level of confidence. All right, so finding that critical value for 95%. So we take 95%, we find alpha. We take alpha, find half of alpha. And then we take 1 minus alpha, and that gives me 97.5. Now this tells me that the area under the curve on this side has to be 97.5% of the total area. So I go to my technology or my table, and I find a corresponding Z-value of 1.96. And that would mean that the negative side would be negative 1.96. There are the corresponding Z-values. You may want to jot those down for 90% and 99%. So you can see this is looser. This one is more tight further out. Margin of error. This is where we were headed. The difference between the sample and the true. So again, we're referring to by the sample, meaning what is our proportion for the sample and what is our proportion for the true population. So P minus P hat. And here's how we establish what that is based on our given information. And it helps us find this confidence interval, okay? There are many ways to do this. I believe this is called the Wald method, and it's the more popular way to introduce the margin of error. So we take our critical value, multiply it by this estimate of a standard deviation. And notice we take our success and failure rate, multiply them, divide by n, and then take the square root of that. Requirements. Much like the binomial requirements, you have to have a simple random sample. Again, it's got to be a discrete. You have to know your P and Q. You got to know the number of successes, blah, 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 blah. And then don't forget, when you multiply the number of successes times your success rate or your failure rate, you should get more than 5. Okay? Now, when you write out your confidence interval, there's several ways to write it. Method numero uno. Write it out as a double, what we call a compound inequality. Yeah? Notice P's in the middle, and here I have P hat minus E, P hat plus E. Or you can use the affectionately known Plinus symbol. Or in calculus and beyond, we use something called interval notation. It looks a little bit like a point with a comma in between, but it just means the interval from here to here. Okay, so it's very much related to that. Keep in mind you want to round to 3 significant digits. All right, and here's what we've been waiting for, people. The big example. Find the margin of error, find the confidence interval estimates, and then can we conclude that fewer than 50% have Facebook's pages? Summarize your results. All right, so this is about, yes, Facebook pages, and Gallup interviewed 1,487 people, and found that 43% have. So number one, check your requirements. Do they fit? Is it discrete? Well, yeah, we're only using whole numbers. Either you are or aren't. Is there a fixed number of trials? Yes. We have 1,487 people, along with independent trials. Is each one independent of the other? Yes. Is there a success and a failure rate? Yes, because we have 0.43 and obviously the remainder that don't. Finally, when you multiply NNP and NNQ, do you get something greater than 5? Yes, we have a large population here. So here's our first estimate at the error. All right, we take our 1.96, this is our confidence Z factor, tail, critical value. We multiply that by our estimate of the standard deviation, and that gives us an error of 0.025, so 2.5%. And that's rounded to 3 spots. So I take my estimate proportion minus the error, and then I add the error to the estimate of 0.43. And that gives me the interval, which again we've seen in the previous examples, between 40.5 and 45.5%. So we come down to part 3, which says yes, with 95% confidence interval, with 95% confidence, I can say that there are 50% of Americans or less that have a Facebook page. Less than 50%, sorry. Which means, interpreting that then, summarizing, in 95% of similar polls, the percentage should differ by no more than 2.5% in either direction of from that found in interviewing all adults, right? So again, we found 43% of them, right? And so again, varying either way from that gives us that region of our confidence interval. Important factors in analyzing. First of all, make sure that there is no voluntary samples. These need to be simple, random samples. You should always be given a confidence interval. That they should never be left out. And again, sample sizes should be provided. They don't always. 4, it doesn't really matter what the population size is. That's kind of independent. The fact that we have a sample is important, and how many are in that sample is important, but the overall population doesn't need to be huge or small. In fact, the ratio doesn't need to be large either. Okay, a little final spin-offs of the margins. We can find, using the upper and lower confidence intervals values, we can find our p-hat by adding them divided by 2. Should be fairly obvious. Likewise for the error, subtract them and divide by 2, and that tells you what your error is. This is probably more unintuitive. How do I find the sample size if you want a 95% confidence interval? You've got to know your success. Well, you don't have to, but this is if you know your success and failure rate. Then take your critical value, square it, divide it by that error, margin of error squared, and that will tell you how many people you have. And I'll go through an example of that. And then if you don't know your population proportion, your sample proportion, then you're going to multiply by 0.25 instead of that value there, right? See how those two are in the same spot? And there's a reason for that if you think about it, like what's the greatest that could be? Well, that is the largest that value could ever be, because 0.5 times 0.5 is 0.25. All right, what sample is needed to see what percentage of adults make online purchases? Assume a prior poll had 80% of Americans making online purchases. Assume that there was no prior poll, so you're doing a fresh one. So again, we're looking for, again, what sample is needed. We start with the 0.05. Again, we take and find the corresponding z-score for our confidence level and our error, margin of error, and then we take and multiply all that out, and that tells me that we need 683 people. Verify that on your calculator. All right, we can do that again this time. We're gonna plug in 0.25 instead of the 80 and the 20. And if there were no previous results, then you would need 1,000 adults. Note here, I rounded this value up. I think it was 1,067.1. You never want to be less. You always want to be over that value. The book closes the section by saying there are other methods, and they detail them, but they are more complex, and I'm going to say you don't need to know them. There is one variation that we might need to come back and talk about, and that is called a +4. You add 2 to the successes and failures, then you add 4 to n, and you continue with your previous assignments, formulas up there that we already discussed. So it's called a +4, and it has greater accuracy than what the current is. It, again, has another name. I forget who came up with this, but whatever. All right. Well, tomorrow we'll cover 7.2. That's it. Best of luck as you work through estimating a population.